Hi and welcome to my maths class. Today we're going to do the theorem that says lines parallel to one side of the triangle. Now, when we're doing this theorem, we will discuss it and we will do the proof. But remember, when you are writing reasons for using this proof, all we write down is lines parallel to one side of the triangle. Now, what does it say? The theorem says that a line drawn parallel to one side of a triangle. So immediately we know, okay, there's a triangle and I know that one side is parallel. So I have a line and I know that this specific line is parallel to the one side of the triangle. So this line DE is parallel to one side of the triangle. And then they're telling us, what does it do? This parallel line does something very specific. It cuts the other two sides. So the other two sides of the triangle is AB and AC. Now it's cutting the other two sides in proportion. That is what it's doing. So this line DE, which is the parallel line to one side of the triangle, is cutting the other two sides in proportion. So let's discuss what they've given us. They had given us line DE, but such that it is parallel to line BC. That is what they've given us. So, what do we need to prove now? They've given us that it's parallel, but what do they want us to prove? They want us to prove that the sides are in proportion, which means that if I had to say AD over DB, I would get AE over EC. The side of one part of the triangle would be in proportion to the other side. So the one side would be in proportion to the other side. Meaning, if this is 5, then this would also be 5. If this is 3, this would also be 3. But remember, I told you when we're working with proportion, I would put in alphabets. Why? Because that does not mean that this length is 8. Neither does it mean that AC is 8. I could have a triangle that looks like this. Now, if you looked at this triangle, you can clearly see that this length is not equal to this length. Neither is this length equal to this length. So remember again, proportion does not mean equal lengths. Now, how do we prove this theorem? First, you are going to draw H and K. But H and K are going to be altitudes, or what you would call heights. They would be perpendicular heights for triangle ADE. We're going to put H and we're going to put in K. But when we're drawing them, they're going to be drawn to the length or to the sides of AD and AE. What I'm actually saying is draw this and make it perpendicular. Label it H, and I'm saying draw this line and label it K. Now when I give you these drawings, you see most children find it a challenge because now you're trying to say, okay, I want to work with base AD, right? And I want to work with base AE. So what am I doing? Because we want to draw H and K, they must be heights for triangle ADE. But if I'm putting my bases here, if I'm putting it against AD and AE, then I actually want that to be the base. But look, if you take the drawing, so you take your book and you rotate your book. When you rotated your triangle, and I tell you, listen, I'm working with my base AE. Can you see? And I'm going to put a perpendicular height here. Can you see that? And I am now going to call this K. Okay? Now, let's take the same drawing. Okay, now I'm working with my base AD. But I am going to put a height this way, and what I'm going to name it is I'm going to name it H. So can you see what I'm doing? I'm taking the triangle and I'm now trying to get the area of this triangle. Now if you look at it, what I emphasized on when we just worked now in the other drawings, H and K, which are heights in triangle ADE. Now what else are we doing? When we're working with this triangle, we use the bases what? We use the bases AD and AE. That is what you did. Look, if I'm working with the triangle here, ADE, I had my height K and I made the base AE. If I worked this way, so I turned the triangle upside down, I worked with ADE, but I had my base as AD. So we drew H and K, which are the altitudes or heights, in triangle ADE, and then we use the bases AD and AE. That is what we're using as the base. So when I'm talking of area of those triangles, I'm going to use my bases as AD and AE. Then what we're going to draw is, we're going to draw line DC and BE. Look at what I'm drawing. Line DC and BE. I'm drawing a line here and I'm drawing a line here. Let's go to our big triangles now. If you look, I'm drawing a line here, DC, and then I'm drawing a line here, BE. Okay, now we also know that these lines are parallel. It's the same triangle. All I did was I tilted the page. I turned the drawing so that the base is looking at you, because you are normally trained to have the base at the bottom. So now when I put the base on the side here, then you can't see it because you're so trained to put the base at the bottom. So if you need the base at the bottom, turn your book, rotate your book so that the base is at the bottom. Now, let us discuss the area of ADE. So look, I'm working with triangle ADE. You're going to tell me it's half, my base is AE, and my height is K. Right? And for this one, you're going to tell me it's half, my base is AD, and you're going to tell me it's times H. That is what the area of triangle ADE is. And this side, you can call it triangle AED. So what do we have? We've worked out the areas of these two triangles, ADE in this drawing and here AED in this drawing. Now, if I'm working with triangle, I'm working with triangle DEC. Can you see that? Now, what is my base? If I'm working with triangle DEC, you're going to tell me it's a half. You're going to tell me my base is CE. And what is my height? What is my height of triangle DEC? Can you see the height is exactly the same K? Because remember, the height of the triangle can be outside of the drawing, and that is what you're doing. Can you see? If you look at this triangle, then there's my height. Now what can you tell me about the triangle area? Now I'm working with the triangle DBE. You're going to tell me it's a half and the base is DB, and then you're going to say it's times height, because can you see this is the perpendicular height of the triangle DBE, but again it's outside of the triangle. So now we've discussed 4 triangles. We've discussed triangle ADE and DEC, this triangle. Then we've discussed in the second drawing AED, and we've discussed DBE. Now, what do we know? If I take the area of these triangles, so I'm working with this first triangle and then I'm working with the second triangle. What do you notice? If I had the areas of the two triangles, if If I take this one, I could cancel the k's, I could cancel the halves. And what can you tell me about the areas? We had discussed it in our previous videos, where we discussed areas that had the same perpendicular heights. If the heights are the same but the bases are different, then their bases are in proportion. Now, proving that, what can we say here? Their heights was the same. In this triangle, both the heights of these two triangles was k. So their heights were the same. So we have their bases are in proportion. So we have AE over CE. And working with the second drawing, we can do the same thing. So now we have AD over DB. So we have two different triangles. We know that their bases are in proportion, and you've just proven that their bases are in proportion. Now let's go further. Okay, so we have two triangles. We have that AE over CE is 1 ratio, and we have that AD over DB is 1 ratio, considering that they are two separate triangles. Now let's look at the original drawing. At the original drawing, can you see triangle ADE? When I name it ADE or whether I name it AED, it's the same triangle. So what can you tell me about triangle ADE's area and the area of triangle AED? It's equal because they are the same triangle. Both of them are the same triangle, even though I am naming it different. It's exactly the same triangle. So these two triangles are exactly the same. Now let's look at the next triangles. So I want you to look at DEC, right? And then I want you to look at DEB. If you look, they both have a common base. Can you see their common base? Look here. And they are between the same parallel lines. Can you see this parallel line? Now what do we know? If these two triangles have the same base, can you see DE is a common base? And then we know it's half base times, if the height is between two parallel lines, then the heights are the same. So what can you tell me about the area of DEC and the area of DBE? The area of DEC is going to equal to the area of DBC. And what is our reason? Our reasoning is because they lie between the same parallel lines and they have the same base. Now if you wanted to, you could say, okay, so the base is BC, if you want to see it this way, right? Their bases are the same, their perpendicular heights are the same. So they have the same base and they have the same height. Why do they have the same height? Because they are between two parallel lines. If those areas are the same, let's go back to what we've done. We know when we have triangle ADE and triangle DEC, triangle ADE over triangle DEC, we simplify this simply linking it to its bases, which gave us AE over CE. Then we had triangle AED over triangle DBE. And when we simplified that, our ratio was AD over DB. Now you've proven this. The next thing you've proven was that AD is equal to AE. And you've also proven that the area of DC is equal to the area of DBE. So if their areas are exactly the same, what can you deduce about their ratios? Therefore, we can now say that AE over CE is going to equal to AD over DB, because you've proven that the areas are the same. So first you had to work with the triangle on one base. So first we covered the triangles on this side, and then we covered the triangles on the other side. Next, you had to prove that the areas of the existing triangles are equal based on specific reasons that you learned regarding areas of triangles. Once you equated them, you proved the ratio. Thank you for watching.